All right, this is CNIT 128, hacking mobile devices, primarily Android, and we're going to do the first part of Chapter 7 today, which is attacking Android applications. So, we're going to talk about some quirks of the security model and the components of applications, which is extremely good to understand. And then more stuff will be done in later lectures. So there are three main components. You have the application container itself, which is your phone, typically. Then you have the communications network, and then you have the server. And as I just mentioned in the news portion, at least as of a couple of years ago in the OWASP Top 10, the #1 application vulnerability is on the server. The main weakness is the API, where they do not, the API is the application program interface where the app on the phone gets to send requests to the server to store and retrieve data and create accounts and change passwords and all that stuff on the server. And usually, it's extremely common that of the available methods, some of them fail to check the authorization of the user. So an unauthorized user can do something they shouldn't be able to do, like change a password or view another user's data. And that's what happened with that stalkerware company and with other companies I've seen. Anyway, all right, so the application container is what we're going to focus on here, flaws that are actually in the app on the phone. So there may be ways to get out of the sandbox and access another app's data. That would be bad. If you can put a malicious app on the device, it can then attack the other apps. And this is extremely common in Android because there's so much malware in the App Store. And of course, getting physical access to the device is a common threat model. If the police seize a phone at a crime scene, or somebody steals your phone, or you leave it behind and lose it somewhere, then they get physical access to your phone, and then that is another vulnerability. Can they get the data off the phone if they have physical access to it? The communications, of course, there's a lot of ways to intercept communications, and this applies to all networking. Phones are always using wireless networking, so of course you can intercept the wireless traffic if it's not encrypted. You can do ARP poisoning to redirect the traffic, to place yourself in the middle, which is called a privileged position, where you're in between the phone and the server. And you can also hack into the upstream providers up there. And if you hack into the server they're talking to, or a router on the way to the server, they can get in. And by the way, there's a big stir right now. I'm involved in this. We're kind of working for critical infrastructure people. Volt Typhoon is the Chinese threat actor that has been hacking into American utilities for 5 years, and one of the main ways they get in is by hacking the routers. The same thing is true of the NSA. The Russians hacked in and dumped the NSA's tools, and it turned out the NSA had developed tools to compromise Cisco and many other brands of routers, and it's the same for the Chinese. Often hacking into the router is the first step, and then once they're in, they implant more backdoors and such. So the server itself can be hacked. The server you're talking to, this is extremely common. This is what finally convinced me to use a password manager. I saw so many password dumps, I realized if I use a password somewhere, they're likely to get hacked at the server and leak it out. And then I'll wish I hadn't used the same password somewhere else. All right, so there are 4 components of Android apps. There are activities, which are the visible pages you see, like the splash screen and the login screen and whatever other screens the app has. Broadcast receivers are like listening network ports, although they're not exactly implemented through TCP/IP ports, but they are listening for signals from other apps and signals from the phone. So if an event occurs, like an SMS message comes in, it can there's an intent send out, which is an internal message to the Android operating system saying an SMS just came in, and some apps are listening for SMSs to come in, and then they will pop up and do something with the SMS. Because, that's part of their functionality. And that's why when you install them, they'll say, this app has permission to listen to your SMSs. So you should know that. Then there are services. These are just background services, just like in Windows or Linux, services running that provide service to other components. And content providers are databases, typically SQLite databases, which store information. And the only thing surprising here is that by default, before API 17, which is quite a while ago, I think that's Android 4 or so, if you are before this version of Android, all content providers are exported by default, which, by the way, is very much what Amazon did at that time. What Amazon did up until about 4 or 5 years ago is all open databases that you put on Amazon Elastic Block Storage were world readable and world writable by default, or at least world readable. And that's why all kinds of people migrated their stuff to Amazon, and then it was all exposed to the world, and they didn't know that, because the default was to just let the whole world see it. And that's both Amazon and Google figured out this was a bad idea and changed the default, but the older systems will still have that. And this will determine the target SDK version. So when you write an app, you specify when you compile it what SDK you're targeting. What version of Android are you targeting? You have the target one, which is the one you design the app to run best on, and then you have a minimum SDK version. It won't even install on one that's so old if you decide what is so old that the user won't have a good experience entirely. And so that's the point here. This is what you compile, and this is the minimum. Those are the values. And the target SDK version is the one that determines whether it will have this behavior or not. If you target an API below 17, then it will have this behavior of publishing a content provider, although I think nobody would write a modern app and target such an old API version. And here's the versions. As of about a year or two ago, as you can see, this is what I mentioned before, they're all over the place. A lot of people are still using versions 4 and 5, a few percent of people, a lot of people on 7 and 9, 10 and 11. So the newest version only has like 30%, and this is because, of course, most people don't update their Android version. They just buy a phone. It has Android on it. They just keep using the phone. And after a while, they buy a new phone, but the old phone gets sold as a used phone, and it trickles down and is used for many, many years. And so there's a bunch of people using really, really old software, which is extremely vulnerable. There are all kinds of known exploits on that old software. And there's no easy way to update them, unless the only way to update them usually is to replace it with a custom ROM and take over the updating yourself, jailbreaking your phone, and that's a lot of work for a normal user. And most people aren't motivated because the phone generally works, and why would you bother trying to change the software just to put on some update that doesn't really seem to matter to the end user typically. So you can decide to export a component, which means you make it visible to every app on the phone. So here you can take a receiver and you can choose to export it. Therefore, other apps on the phone will be able to see this, and that you're doing this because you're offering some kind of service and you expect something to come from another app to go here. If you don't specify it, it'll be exported implicitly if you're in the really old target SDK. You just define a broadcast receiver. A provider. A provider will be exported, not a receiver. All right, because they assumed if you have some kind of database storage, you intend for every app on the phone to be able to see that, except in a special case. And of course, that's not a very wise default position. So here's implicitly exported. If you're using an intent filter, then you're exported, because of course here you define an activity, then you define an intent filter. That means there are signals coming from other apps on the phone called intents that will trigger this activity, and therefore, obviously, that has to be exported. It has to be visible to other apps. So you don't have to say that. Here I listen for an image. So if you get an email with an image, it will activate this part of my app. It's probably something like a picture modifying app or drawing app or something. And so when an image comes in, it automatically it alerts this app, open it in my apps, because the user probably wants to use my app on that image. That's the sort of thing. So you can find out in the manifest, and we'll do this soon. In fact, maybe I can do it live. Let's see if I have Shiv on here. Let me check my downloads folder. Let's see, all right. All right, I get there again. I'm sort of losing control here. All right, let's get the downloads folder and see if I have Shiv. .apk. And I do. All right, good. So we'll just analyze this in Android Studio. And I'm going to do it the way I put in the instructions here. There's various ways to do it. This is an extremely useful feature of Android Studio now. You do not need to load an app into the command line and unpack it with APK tool anymore. You can just put it in here. You can also do file analyze, but since I've got it in my search menu here, you take Shiv and just drag and drop it there. There you are. And now it will analyze it for you. So you can get this out of here and get this out of here. and now you can see the app. Here's the contents of the app. For example, here's the Android manifest, which is one of the main things you want to look at. You can see it right here in Android Studio, right from the APK file. So now we can learn a lot about this app. So here's the app. This is the way apps always are, by the way. They have a URL backwards. So it comes from mwr.com as the company, then they put example, then they put SIB. So here's the permissions: read external storage, internet, read keys, and this is a new permission defined just by this app. This is an Android default permission to access the internet. Here's a special permission they're defining for this app. And here's another one to write keys. Then application, I'm not quite sure what that is, uses SDK. Here's the minimum and target SDK version. So it targets version 17, so it's a pretty old app. And all right, then we're going to have an activity with a label that doesn't mean much and another activity. Then we're going to have an intent filter on this one, where it's listening for launcher. This is the, when you tap the icon and the app launches the first time, that's what this is. So this is the intent filters that will pick up that you are launching it, and therefore it'll launch this activity here. So this one here, called main login activity, is the one that opens when you first launch the app. That's how you specify it. Here we got a page of settings, page add entry, short login. This is a password manager app. There's a welcome activity. There's a place to put in a PIN to authenticate. There's an authorization service that will decide whether you put in the right PIN, some kind of cryptographic service to encrypt the passwords you put in there, and other things. So you can see all that, and that's it. And some kind of backup to back up your passwords. So those are the, and this is a provider. This is a database. There's a database storing the keys with a path keys here, which is, there's another provider called File Backup Provider, so that's what the manifest is extremely helpful. It gives you a general overview of the app, and you can do a lot to it just from what's in here, and we'll be doing that to that Chinese spy app probably next week. I'm having more trouble getting that project going than I thought I would. Let me check for comments. This code actually looks more like if the user wants to send an image from the app. You know, I'm glad you caught that. Thank you. It was a send, to send the image somewhere. Good. Okay. Good. I appreciate you catching the parts I'm not getting right. That's good. All right. So you look at the manifest, and you can see the services, which we saw, and you can see the content providers, which we saw. So you get a lot just from the Android manifest file. All right. So now root and system users can interact with application components even if they are not exported. Just like root and system can go into the folder and see the data, even owned by anyone else. The same thing on Linux systems. Root can go in anybody's folder. Normal non-root users are only allowed to see their own data. And so if you don't export in the manifest, it's private and only intended to be used by internally by the app, and only attackers with root privileges can attack those things. There are protection levels for newly defined custom permissions, like the ones we saw here. The best protection is signature, which would mean it looks at the public key signature on the app, the certificate, and it will only let apps signed by the same company see it. So that you might do if you're something like Microsoft Office and you have a fleet of apps and you want to share something among the Office apps but not with anybody else. That's, of course, the most secure process if you can do it. Now, here's a downgrade attack that worked in Android before Android 5. The first app that sets a permissions protection level wins, and later apps can't change it. So what you could do is Skype defined a permission to make a Skype call. And you could have a malicious app that defined that permission first and made it public. And then when Skype defined it, it wouldn't change it back. So that was a trick. And I've got a project where you do that if you're willing to make some really old Android emulators. You can see that happen. All right. So to attack application components, I mentioned these intents. Intents are these objects that define a task to be performed that are sent into the system. They are like interrupts. So you can send an intent to a broadcast receiver. You can send to a service to start it. And the intent is a generic item. So if you are, you have some pick photo via button. It says which photo do you want to do something with. You click a button, and then it starts gallery. It sends an intent to open that in a gallery, and then when you're done, you click some kind of return, and it returns. That's what intents are for. You move from one activity to another, or from one app to another. So here you can start another activity via an intent. This is how you do it in your code. You define an intent and just start activity I. So you specify the class. This is the Java code to do it. Those are now explicit intents state the component that must receive it. And therefore, it will not hunt for which app to call. It will tell it, call this app specifically. And that would be fine if you know what app you're calling. But if you have a generic activity like an SMS comes in, and you might have multiple SMS handling apps, the operating system won't know which one to open, and so then it'll pop up a box saying, which player should I use? You have several apps that can handle this sort of data, so which one do you want to use? The reasonable thing to do. So here, it's going to tell the Android system to display a web page, so it's going to parse this URI and it's going to start an activity just saying, I want to view this web page, but it didn't say what browser to use. This is a good practice because you don't know what browsers they have. So if they only have the default browser, it'll use it. If they have more browsers, it'll pop up a box saying, which one do you want to use? All right, we check for comments. All right, good. All right, so the intent filters, you can, to determine when an intent will trigger your app, you can determine whether you want to match the action, the data, or the category. You do have to have action defined. So here's things you can use. You can use scheme. Scheme is the start of URL, like HTTPS or telnet or HTTP or mail to. There's a bunch of prefixes here, and Skype defined a new one called Skype. So you can, that's the scheme. So anything that has this scheme should be processed by my app. You can also have the host part of URL. In this case, it would be google.com. You can trigger on that if you like. You can go to the port, the port number at the end, which is 80 or 443 by default, but it could be something else. You can match part of the pattern or all of the path, and you can look for MIME types, which is attack data. And there was an example earlier where I was listening for images coming in as a MIME type. So these are things you can specify what type of intents you wish to receive. So the Activity Manager is a command line tool that we'll use quite a lot in the project to mess with Android. So you can, once you're in ADB and you have a shell on the phone, you can use Activity Manager to directly interact with apps. And often, this ends up having effectively the same flaw as an open API. You can often go into apps where you shouldn't go, and that Chinese surveillance app I found had this flaw. I installed it on a phone, and it wouldn't launch at all. It said you have rooted your phone, and you can't run it on a rooted phone, but I could just launch the activities directly this way on the rooted phone. So security was not very good. So here, I can just launch this in action directly here, and therefore you can jump to a page in an app, and you don't follow the path that the developer expected. You don't have to start at the first page and progress through the app. You can jump through to other pages if they allow this. And so you can start various things. You can start an activity based on intent, and there's a whole lot of options here to control it. It's a very powerful command line command. All right, and there was a tool called Drozer we used in previous classes. We're not going to use it now. It didn't seem very valuable, but we'll play with some good stuff as we go ahead. So here's some examples that really happened. There's a device lock screen requiring a password, and what you could do is run an exploit to just bypass it and get on the desktop. And I think that one, you would just send this AM. You would just start an internal Android activity which would get you past the lock screen. So if you have the ability to execute an AM command, you can bypass the lock screen. Now, of course, in order to send this, you'd have to have something like USB debugging turned on, and phones are not supposed to have USB debugging turned on. There have been some sent with USB debugging turned on by default, but anyway, it's a flaw. It shouldn't let you bypass the lock screen without putting in your PIN. Tapjacking is another common one. This is attack on all sorts of websites where they lay something false on top of buttons, so you think you're tapping on one thing, but those taps are in fact going through and having a different effect. So here, you'd have, you're installing an app, and it opens this page asking for you to approve some permissions and accept it, and now they put up a game and say pop the balloons. So you click here to pop the balloon, you click here to pop the balloon, and now you're clicking accept, and you don't know that. This is one version of this. Also, it has recently used app screenshots. When you close a window, it shrinks down, and so there are conditions in which you see the shrunken version, and so those shrunken versions may contain sensitive information. Same thing's true of thumbnails on most operating systems. Another flaw. And then there's fragment injection. Fragments are part of a URL that comes after a pound. For example, if you go to my website, let me go to my browser here. If you go here and you click some of these, on my page here, yeah. If you go to this page and you click projects, the actual URL doesn't show up in this browser. I'm going to copy link address and paste it into a text editor. All right, there it is. Oh, my goodness. Oh, that's why, pardon me. This part, there you are. If you look down in the corner, you can see it. It's this, I'll copy it and put it in my text editor so you can see it. This uses a fragment. There's a common trick. It's the same page, then you put a pound lecture. Then you put an anchor tag on the page. And so when you click a page with a fragment at the end, after the pound sign, all it does is move on the page. So here I am at the top. When I click that, it just scrolls down to where the slides are. So it's a way to jump to another location on the same page. But it is a valid part of a URL. And so here, they were able to use a fragment, and they could trick it into changing a pin without knowing the old pin. And I mentioned this is another flaw in that Chinese surveillance app I found. I was able to launch the page that changes your password, and it does not ask you for your old password. So I think I could break into anybody's account by doing that. I could change the password to something I know without knowing the old password. This is a fairly common flaw in web apps and mobile apps too. And this is what happens. If you send in this injection with a fragment, then it directly takes you here to choose your PIN. So the same flaw. I can choose your PIN without knowing the old PIN, so I can get in. The PIN is not a security barrier. Let's take a look at a Kahoot. That's okay, that's all good. We are 7A. All right. The thing about passwords, another thing Steve said in the podcast I thought was pretty good, there are people who when they make an account, they just type in garbage and they don't bother to remember their password at all. And every time they log in, they just go to, I forgot my password, and then they get an email. And that is kind of what leads to thinking about, the password didn't actually accomplish anything anyway. You might as well have just made sure they could read an email, and that proves they are who they say they are. That's really all you need. CSI Tenderloin, boy, they'd have some work. Tenderloin has some scary stuff in there. All right. All right, so how do you send an intent? All right, you can do it with AM. You have to have some parameters, but AM is what you use to do it. All right. Android Manager. All right, what components were exported by default in old Android versions? providers, just like Amazon, they assume if you're putting up data, you mean for everybody to see it, which is a pretty screwy default. All right, what intent filter can match any part of the data? You can use the path to match any part of it. All right. So you can respond to any signal that contains a certain word. All right, so what intent filter is at the start of a URI, like HTTPS? That's a scheme. All right.